Last week's episode was a bit of a doozy. It was like 2 solid weeks worth of work condensed down into just 42 minutes, which still is like the longest episode I've ever made. So this week we're just gonna take a big deep breath, calm down a little bit, and do something a little easier. We're gonna break out the PDP-1144 here, and we're gonna try and solve the halting problem. And I think the first step to that is just to Google the halting problem here. And let's see here. The halting problem, the halting problem is unsolvable. Well, to quote Wikipedia here, the halting problem is the problem of determining from a description of an arbitrary computer program and an input whether the program will finish running or continue to run forever. No general algorithm exists that solves the halting problem. So there you go, we can't solve the problem. I want to thank you all so much for watching, and I hope to see you in the next episode. I'm just kidding. We're actually going to have a proper episode today, but we're not going to try and solve that halting problem. We're going to try and solve the halting problem with this big machine right next to me. That whole intro was just a bit of a hat tip to all of you guys that left hilarious comments in the previous episode in the PDP-11 series. This PDP-1144 is a pretty special machine. It's the last non-LSI or large-scale integration PDP-11 that was ever built. So that just means that the CPU is spread out across about 6 cards, and it's using nothing but discrete logic like 7400 series chips or AM2901 based ALUs. So I guess that would make it medium scale integration. I don't really know what classifies that as, but everybody calls it the last non-LSI PDP-11 out there, and I'm pretty excited to get it going, not just because that's a cool PDP-11 to have in the room, but also because there's this big bad Fujitsu Eagle hanging out down here, and I love me some good spin and rust, and I really want to see if there's, first of all, anything hiding out on this drive. Second of all, I want to get it formatted, get it up and running, and have this PDP-11 using that as its primary storage drive. So we've got a lot of work to do, and in the previous episode, we almost got this 1144 up and running. After just getting my butt kicked for a long time by the power supply in it, we managed to sort it out, had a bad PNP transistor in it, and that brought the whole thing back to life. So we have all good voltage rails, and it seems to be working. It's actually communicating with the data terminal. Things are showing up. I can type things, input is going back into it. Things seem to be working up to a point. Anytime I try to do anything with it, like tell it to boot from the drive or something like that, it always just says can't halt CP, which I think means it can't halt the CPU. And there's a little toggle switch on the front here that says halt. And if I flip it over to that, nothing happens. If I type halt on the keyboard, nothing happens. I have no idea what the problem here is, but I think the first step is to kind of pull this front panel off and start seeing if that we've got maybe a short or a bad switch up here. Maybe it's something as simple as that, but I know my luck with this machine. I'm betting it's something far more sinister, much deeper within the machine. So, well, we just got to get to it. So I'm going to pull this guy out, put it on the bench, and get to work. Hopefully we can get past that halting problem. I'm not going to solve the big one, but I want to solve the little halting problem going on here. The first step here is to actually undo some work I did in the previous episode. We'll pull out the console interface module, and my camera is going to have an absolute fit about what to focus on. But the reason we're pulling this out is to disconnect the cable that goes to the data terminal. In the previous episode, I didn't have a null modem cable or adapter, so I modified this one by just swapping the RX and TX lines. However, this isn't a true null modem modification, as the flow control lines are all still untouched. So I want to revert this cable back to the original layout by re-swapping the RX and TX lines. And then I'll plug in a proper null modem adapter that I ordered up. And with everything put back in place, let's fire this thing up and make sure we're still where we left off in the previous episode. And wait a minute, last time we couldn't halt the CPU, and now we're getting CPU didn't start? If I type HA for halt into the console monitor here, it says already halted. That's weird. Looking on the front panel confirms it. The CPU isn't running at all. And I think we might have some problem with the card edge connectors here. I put 4 memory cards in before I put this up for storage last time, so let's pull all those out and try again. And yeah, there we go. Back to failing to halt, broken like it should be. And sure enough, like before, the front panel switch still doesn't seem to do anything. So let's do the easy stuff first and pull the front panel off so we can check the switch. Holding my probes like a pair of chopsticks, the switch seems to be totally fine. Good continuity with the switch in both directions, but while we have it out, let's pull the front panel PCB out for a proper inspection. And that is hilariously sparse. Just a couple of LEDs, resistors, and some switches. Alright, I think it's safe to assume the front panel isn't the fault here. Perhaps it's bad connections on the back plane, so let's pull all the CPU cards out, and with them on the bench, I'll go through and use contact cleaner and a shop towel to clean the contacts of each board up. Then on the back plane, I'll spray down some deoxit into the slot and insert and remove the card multiple times to help clean the sockets out. The backplane on this thing is ridiculously large, so this actually polished off my can of deoxit. I had to place an order for a new one after this. With everything clean and reinstalled though, let's give it one more test, and yeah, no change at all. Well, at least we know the basics are taken care of. All right, I think I'm making some progress. I've cleaned all of the sockets and all of the edge connectors. I'm like 95% certain that we don't have a flaky connection going on here. I've also pared the CPU down to the bare essentials, which is still 5 cards. We've removed the floating point unit and the commercial instruction set cards, which fill up some of the slots up here in the front. Everything else here I think is absolutely required for it to run. I also have brought it down to just a single memory card, which is actually one of the 1 megabyte cards because it only uses the 5-volt rail. The 128 cards use the plus and minus 12-volt rails as well. So I'm trying to minimize the amount of things that we're leaning on here. I've also gone through and confirmed that this memory card is set up to start at base address. So everything should be set up somewhat correctly, at least for the memory card. I don't know, there's a lot of things going on in the CPU that I'm not sure about. And there was no change going on. We had the same thing. We couldn't halt the CPU. But when I got this PDP-1144, it was an insane collection of deck equipment. Thank you so much for that. But I also got a ton of spares, and I actually have a spare card for every card except for one of the CPU cards, the 7098 back here. I don't have a spare one of those, but the 7094, 95, 96, and 97 I all have spares for. So I went through and started swapping them one by one, and check this out. When I get to the 7095, we now have the opposite problem. If I flip the power switch on here, we get console V3.40C program, console halted at 165714, and then it immediately jumps into this console thing here where I can do interesting things. If I type HA here like to halt, it says it's already halted. If I type EX for execute, I don't know what that means. But if I do BO for like DX01 to boot, it says no ROM for that. So we have actually made legitimate progress, but this CPU is like perpetually halted now. So we've got the opposite problem in our halting problem. The boot ROM message is really interesting to me because that might mean that enough of the machine is working that it's actually looking for a drive control card to try and boot something off of a drive. But the halted message is also really interesting to me. It seems very strange that you would turn the machine up and it would come back and immediately say to you, halted. But I don't know, maybe I've got some settings set incorrectly on how to look for boot ROMs, and once we have drive control cards in there, we can tell it to immediately start booting from a drive control card. I think I'm kind of spoiled by the Centurion, which has a nice D equals prompt that allows me to select which drive to boot from. PDP-11 I think is a little more obtuse, and if that's the case, maybe somebody else has come across this exact halted message and they've figured out how to overcome it or what that halted message even means. And so I put halted at 165714 in quotes in Google, and I got one hit, which is this that I've printed out right here. It is a post from 1998. And there's some pretty interesting things going on here. It says, Okay, so boot DM booted the 1144 from the RK07. Thank you, Tony. But I'd like to know what the rest of the commands do. This is the dump from help. Then it says console v3.40c program console halted at 165714. Then he types HE and gets a list of commands. I can recreate this exactly with this machine, which is pretty interesting because this was the only hit on Google. But it gets even more interesting because if we look at who made this post, it is Mitch. And I'm pretty sure, like 99% certain, that this is the very same Mitch that hooked me up with the insane load of deck equipment, including this PDP-1144. So Mitch, all the way back in 1998, could have had this machine up and running and apparently booting from an RK07. So seeing that halted at 165714 might actually be totally normal, but I don't have an RK07 to plug this into and try to boot from. I've got the Fujitsu Eagle, but I'm still not entirely sure what control card I need to stuff in here to get the Fujitsu Eagle working. And I want to make sure that this machine is in a known good working state before we start trying to diagnose the Eagle and the drive control card for it. So I need to figure out some way to kind of start testing this out and make sure that we've got something known good here. And I started asking around on the Discord, and Mattis Lind, I hope I'm saying that correctly, came up with an excellent suggestion. He said you should give PDP-11 GUI a shot. Now, I have never heard of PDP-11 GUI. I probably should have if I'm messing around with these things, but it looks like a pretty righteous tool. So I've got OBS running on the laptop, so you guys should be able to see a nice screen capture of exactly what's going on with PDP-11 GUI here. So we'll go ahead and flip the machine on here. As it spins up, we can see in PDP-11 GUI right here, we get console v3.40c program, console halted at 165714, the exact same message that we were seeing in this post by Mitch. So there we go, we've already been able to recreate it, and we can type stuff in here just like we were using this as a data terminal for the PDP-11 itself. We can type HE and get a list of help commands out of this. But what PDP-11 GUI is so much more than that. We can do some interesting things, and I'm just now starting to learn how to use this program, so I'm gonna fumble my way through this. But if we go into programming here and we click macro 11 source, macro 11 listing, execution control, and disassembly, we get all these extra windows that pop up, and you're running out of real estate real quickly, but there's things going on here. And one of the things that macro 11 source lets you do is load in different MAC files. So we can do mem sizing, for example. This is a memory sizing program. If the simple tests work, the next step is to find out how much memory is in the system. Without memory manage on, whatever. So I think in order to do this, we do new program, compile, load, and reset. But we want to set the start PC to 01000. So we do new program, compile, and load. And it's going to actually deposit this program directly into the PDP-1144. And then it's going to execute it. And stuff happens. But we actually just executed something on the PDP-11 here. Because when you're in this console monitor here, you can actually view and directly deposit things into memory. And if you can view and deposit things into memory, you can dump in lots of stuff into memory and then execute that to run programs. This ran a program, and it looks like it halted and highlighted some stuff in the macro 11 listing and in the disassembly, and I don't know what any of this means. So we need something that is a little more tangible for my simple brain. So what we're going to do is we're going to close macro 11 source here, we're going to close the disassembly, and we're going to close the macro 11 listing. And we're going to go to memory, and we're going to open memory loader. And we're going to load in a paper tape file. That's this one, DEC11 AJPB-PB PTAP. With that loaded in, we'll click load, and you can see we get this huge list of just octal values. It's massive. And we want to deposit all of this into memory because this is like reading in the binary straight off of a paper tape. So if we hit deposit all, it's going to deposit all of this into memory. But oh man, this is going to take a while. The last one deposited rather quickly, but you can see this one is moving at a glacial pace. I'm gonna have to time lapse this one because I think it's gonna take a while, and you guys don't want to see me sit here for I don't know how long, 15-20 minutes twiddling my thumbs while this thing deposits. But this is potentially good news because it looks like we're depositing values successfully into memory, just as if though we were reading those values off of a paper tape. This is very exciting. I'm not sure why it takes so long to transfer over all of this data. It's moving at 9600 baud, so it should really be able to dump all of this in just a couple of minutes instead of like a full-on 30 minutes, which is what it actually takes. Maybe we've got some weird flow control shenanigans happening that's slowing it way down. But either way though, this is a pretty effective way to get data into the machine without actually having any kind of paper tape reader or hard drive hooked up to it. And well, yeah, 30 minutes later, it looks like it's finally finished dumping in. So we should have all of that data in memory. Now we just need to restart the machine and execute that. So there's a reset and start button here, and it says start PC is 016104. And we can actually see that in the memory loader, it says entry address 016104. So it automatically filled that in for us, which is nice. So we'll just hit reset and start here. And yeah, there you go. PDP-11 basic version 007A. Let's hit enter here. Ready. We're running basic on this machine out of memory. Let's try to run a program here. Let's do 10 print hello world 20 go to 10. Infinite loop of hello world. Here we go. Run. Yes. It's running hello world out of basic from memory that we loaded into it. This means that a large majority of this machine is actually working. The CPU and the memory is almost at 100%. I do not believe that BASIC uses interrupts or DMA, but everything else seems to be working really well. So now we're at a point where we need to start loading more programs into it and executing more difficult things, which we need to do with some kind of media, hard drives or floppy drives or something like that. And well, we've got two avenues that I want to try and tackle for that. And the big boy Fujitsu Eagle here is obviously the end game play. This thing is pretty wild. It is a 10.5-inch platted hard drive, weighs an absolute ton, has something like 500 megabytes of storage, and I am very excited about getting it up and going. And it's also one of the primary driving forces behind getting the 1144 up and going. But this is a big unknown, and I do happen to have a control card for it. I think this is an Emulex control card that should do the SMD interface that, well, the Fujitsu Eagle here uses. But I have no idea if this is a good card, a bad card, or even how to set it up and get this plugged into the system or how to use it within the system. And once we get it up and going, if there's nothing on this drive, then there's nothing we can do with it. We need some kind of removable media so that we can get data onto the drive if it's been low-level formatted. And for that, I think we're gonna use these two floppy drives that are right above it. Now, these are not deck-built floppy drives. Those were the RX-01 and RX-02. These were made by Data Systems Design, I think. So these are DSD floppy drives, which means that the drives themselves are pretty standard 8-inch single-sided floppy drives, and so they should be able to be cleaned up and work pretty easily. But their interface to a PDP is a little more confusing. I have I believe, the correct card that goes with them here, the Data Systems Design A4430-4. And I think that all we really need to do is plug this card into the backplane, plug this into here after we get everything cleaned up and mechanically correct, and maybe we should have RX02 emulated floppy drives on there, but this card has a very interesting problem, and that is that the place where you plug the ribbon cable that connects this card to the controller board that's in this unit here is here on the side of the card. And if you slide this into the back plane, this side of the card has a card edge guide on it, and that plastic guide slams into this, and you can't plug it into the back plane, much less you can't even plug a ribbon cable into it. So maybe this doesn't plug into the far left slot, but I'm scared of plugging it into any other slots and any other configuration, because if you get it wrong, you could be slamming voltage down things that aren't supposed to have voltage, and you could fry the whole thing. So I need to find the manual for this, or talk to somebody that has used one of these before and knows how to use it properly, and learn a lot more about it, because it sure would be nice if I could get these floppy drives working on the PDP-1144, but who knows, maybe this doesn't even work with the PDP-1144. So we got a lot more research to do on this, but again, none of this has anything to do with solving the halting problem, which I would say we have definitively solved because we ran basic on that machine. Granted, it took 30 minutes to load it in off of a simulated paper tape. It would be nice if we could speed that up. But that tells me that a lot of the machine is working and we're ready to push forward to the next step, which is what we're going to do in the next episode. So I want to thank you all so much for watching, and I hope to see you in the next one.